Hi everybody around the world, and thank you for joining us once again for another technical presentation of our webinar series Hoppy Topics. Today we talk about hop aroma in beer and its behavior over time. My name is Sandro and I'm working for the technical support at Hopsteiner, Germany. For everybody who's new, I would like to give a very short introduction. Our webinar is a free online seminar with presentations about various hop-related topics. All of us have limited possibilities to travel and meet each other, and therefore we'd like to additionally offer this kind of online support. In this way, we want to keep you up to date on the latest research in hops. Before we start with the presentation of today, I'd like to point out that we'll be happy to receive your questions and comments. During the webinar, your microphone and your camera remain switched off, but you can address your questions at any time through the Q&A button on the right side of your control panel. I will pick up the questions in the end of the presentation. The presentation itself will take about 40 minutes, followed by the Q&A session, so in total we have about 1 hour. Here with us today we have Frank Peifer, our technical director at Hopsteiner. Frank started his brewing career 35 years ago after receiving his degree as an engineer in brewing science and beverage technology. Prior to his career at Hopsteiner, he worked at the Staatsbrauerei Weihenstephan as director of operations. In 2015, Frank joined the German Hopsteiner team as technical director. He provides technical support to many breweries across the globe. He supports R&D activities for new product developments and best usage of hops in the brewing process. Besides, he's also responsible for the processing and packaging plants and our technical advisor for the optimization of hop processing technologies. Frank, these days many more hop bales of the recent crop were delivered, and I'm sure you already had the chance to check them, the flavor sensory-wise. So as we talk about the hop aroma in beer today, you might want to give a very short information about the flavor characteristics of this year's crop. Now it's up to you.
Yes, Sandro, thank you very much for your kind introduction. So when I'm looking out of my window, I can see the hop bales arriving here, going into the cold warehouse before we send them to processing. And what we can say about the harvest so far is that it's regular harvest. We have good values. We have good values regarding the alpha. We have good values regarding the utilization of kilograms per acre, and we also have good values regarding the hop oil content and also the certain hop oil fractions and aroma compounds. So it's let me say a good harvest, and all the varieties, they show their typical characteristics in this year, in this crop year 2020. So let's see what happens in the market, and let us go now to our topics for today. And if my computer will work, I can start. Okay, so topic for today will be about hop aroma in beer, and especially about the stability over the shelf life of a beer, because that's very important. With a look on dry hop beers, we see something happens on the shelf, and that's what I want to describe with my presentation today. But before I start, I want to say hello to everybody around the globe who is watching us today. This is a live webinar. I hope everything works well. And with a look on the points of the topics, at the beginning, I will give you again a short introduction about the beer relevant hop aroma compounds. I did it in the past in this series several times, but we know that we have new guests now there at the computers, so I need to do it again. And then we go to the first point, that is how which influences and affects the beer before packaging, before filling, because something can happen after dry hopping, for example, and that will have a big impact on the aroma profile, on the flavor of the beer. Then we see what happens on the shelf. So when the beer is packaged, it's transported to a supermarket or whatever, it stays different conditions, different temperatures, They can be also influenced by daylight and so on and so on. And that has all an impact on the quality and on the flavor and taste of the beer as well. We will have a look on different containers, how the beer behaves, how the aroma compounds behave in bottle, in keg, and in can. There we have very nice results from our research from the past. And we also will have a look on the turbidity, what happens with the beer that is very cloudy on the shelf, in the bottle or whatever, and then after a while it needs to settle down. Components, hazy compounds begins to precipitate, and that can also have an influence on the aroma spectrum and also on the taste of the product. And what we know, maybe we know, is the impact of daylight on bitter substances that can also change the flavor of the product. And at the end, I will talk a little bit about the mystery of linalool, because linalool is a very specific hop aroma compound. It's a key aroma compound for some applications in the brewery. And there's something behind that we should know when we're talking about values in the beer, especially in aged beer. So let me start with my talk about the different or the main groups of aroma compounds in hops, and how they are presented in beer and how is the importance in beer processing. We know the monoterpenes and the sesquiterpenes, especially here for the monoterpenes, myrcene is very common, also limonene and alpha and beta pinene. We know from these compounds that they are very, very volatile. So they are non-polar, and they tend to take every chance to leave the beer wherever it is possible. A very dominant transfer, for example, for myrcene, we only find in dry hop beers. Threshold is around, some people say, about 40 to 400 microgram per liter. And if you have a typical hop addition into the kettle or as well in the whirlpool, normally the beer will show very low levels of myrcene below the threshold. And for this beer, there's normally no impact by myrcene on the aroma profile. The sesquiterpenes, they are also something to describe a variety, especially farnesene is present in this in the SARS derived hop varieties, but also caryophyllene and eumelin can help to describe a hoppy flavor. And these values or these ratios in the hop oil, in the total hop oil of a variety, is very typical for the variety. But what we know regarding these components, they are also volatile, and the aroma threshold is sometimes very high. Let me say for caryophyllene, it's more than 300 microgram per liter, and it's hard to achieve a reasonable concentration that they have an impact in flavor and taste of a beer. Coming to a very important group, these are the monoterpene oxides. These are alcohols with a very good solubility. We all know the linalool, and also the other partners are very common and very important for beer production with hops: geraniol, beta-citronellol, and alpha-terpineol. And we see very important compounds in late hopping and also in dry hopping additions. And this compound will be able to be installed in the brew house as well as later on in other applications, and with a very good utilization until the beer is packaged. Next group, we have the aliphatic aldehydes and the ketones. They are a little bit more volatile than the monoterpene oxides, but especially in dry hop beers with a very good transfer rate, so they have a good solubility. We find a fruity and flowery note, especially from the ketones, and there is a noticeable aroma profile coming from these compounds, even in very low concentrations in beer. Very important, and a lot of noise is going on regarding the group of the autoactive thiols. You can also call them mercaptanes, we see that sulfur is involved in these molecules. And one example is the 4-MMP that's very dominant in the variety Cascade, which forms this typical blackcurrant character in a certain concentration. When this compound is overdosed, this turns into a cat piss-like aroma, so that is not very pleasant. Everything depends on concentrations, not only for the thiols, also for the other compounds I was talking about before. We also know this 3-MMP, that is the Nelson Sauvin typical white wine-like taste, and a lot of other thiols coming from hops, and they have something together that is a very low threshold in beer. And before we were talking about microgram per liter, and now we are talking about nanogram per liter. And especially the 4-MMP, the threshold is around, let me say, 3 or 4 nanogram per liter. And so detection in the past was very hard to achieve, but now the analytic goes much better than in the last years, and we will see more and more coming up from this part in research and development. Especially in our house, we are working on this, and we also know that there are precursor substances of these thiols involved in the formation of hop aroma. So we will see something more coming up on the thiols in the near future. Coming to the last group, important group of hop aroma compounds regarding beer processing. These are the carboxylic acid esters, and a lot of them are present in hops. A lot of them are present also in other fruits in the world. And these compounds, together with the other compounds I mentioned, they form all these flavors and tastes that we can find in fruits, in hops as well, and other growing plants in the world. And the carboxylic acid esters, they are not that much volatile, and also when you have late hop addition in the kettle or in the whirlpool, you find some of them remain in the finished beer. And sometimes we can talk about synergetic effects with other hop aroma compounds where the carboxylic acid esters are involved. This is the summary of my first slide, so that is an overview for you where you can have a look on if you want. And now let's come to the things that can happen before we send the beer to packaging. And what we found in the past, this was found by chance, a lot of inhomogeneities in the process, and we have to avoid inhomogeneities when we start to fill the beer from a bright beer tank, for example, into certain containers. So to find a homogeneity is also something we have to achieve before we start filling. That was by chance a beer that we filled from a small BBT. The beer was in the BBT for a week. It was completely free from hop particles. It was also not that cloudy anymore. We found some sediments and we removed the sediments, and then we started filling, and we took samples at the beginning of the filling process. That was the beer from the bottom and from the middle, and also we had samples from the last beer that was filled up, and that was the beer that was in the tank from the top. And by surprise, we found very high differences regarding certain compounds, especially for these volatiles. For the mono and sesquiterpenes, there was a big difference in between the beers we sampled from the bottom and here from the top. Let me explain this sheet a little bit. For caryophyllene, for example, we had a very high concentration. It was 100% higher than the beer we found in the middle. And the beer that was on the bottom, that was filled up first, had around 50% lower concentration of caryophyllene compared with the beer that we found in the middle of the tank area. And that is the same for all these monosesquiterpenes, they all behave the same. And that shows us that there's an inhomogeneity even in a bright beer tank. We're not talking about a tank where we made the dry hopping process that was removed and then transferred into the bright beer tank. It was a very small bright beer tank, so we can say that when we filled the tank at the beginning, there was an homogeneity, but after a week, when we started to fill the beer, there was an inhomogeneity, especially in this way. Later I come with another slides to this phenomenon again, and then we can maybe describe what happens there. But have a look on this 2-methyl-butyl isobutyrate and the linalool here as well. We see not any dominant deviation of the concentrations in between the layer and the area of the tank where we took the samples. This one here is isoamyl acetate. That is a fermentation byproduct that we always measure because it's like something like a zero value to compare our analytics. But these are the big differences here in between the terpene alcohols, this ester, compared to the mono and sesquiterpenes behavior. Then something about filtration. It was already released by us in the brewing industry and also in the international brewing industry as well 2 years ago. And what we found out was just a simple filtration of dry hop beer, just only with diatomatic earth. There was nothing else involved. We had no cellulose material involved there, but just a candle filter and filtration with kieselguhr. We have seen that we found very high losses regarding the myrcene, humulene, and beta-carotene. That these are the mono and sesquiterpenes, and intermediate losses for this ketone and for these 3 different esters, and very low losses or nearly no losses for the group of the terpene alcohols. And also here we have found an ester with no losses and also a ketone. So the esters and the ketones, they behave a little bit different. Some of them have a very good solubility in the beer, and they can pass the filter easily. Some of them not, but especially for the terpene alcohols and for the mono and sesquiterpenes, there's a very big difference. And here, especially for myrcene, we had losses about 80% in the beer that was leaving the filter, and linalool was nearly not involved in any losses in this simple filtration with just diatomatic earth. So something must happen there in filtration, and we know that kieselguhr filtration is a diff bed filtration, and we can only eliminate components if they are bounded to a solid particle. Otherwise, if they're in a beer as a soluble, as in solution, they will pass the filter without any problems. So that is something that I want to mention here. I think that these compounds with high losses, especially these guys here with high losses, they must be connected to a solid particles. Otherwise, they will not be able to filter out with kieselguhr. So then we come to centrifugation. So what is a very late stage of processing the centrifuge before the bottling or kegging or whatever you're doing. Maybe you have a flash pasteurizer in between, but that is not common for dry hop beers. We also found something that was very interesting in this small pilot tray that we did here in our brewery in Mainburg. We had a centrifuge from a well-named supplier, and we had it was not a big tank, not a big volume of beer, but at least it was 160 liters, and the beer was sent into the tank, and there was a lot of yeast involved, a lot of hazy compounds were involved. And then we started centrifugation, and we took samples at the beginning, before the centrifuge and behind the centrifuge, and compared what happens, especially the losses. We did it again in the middle and at the end at around 160 liters. The beer in the tank had a little bit time to settle down. That means we have seen that compounds were able to build sediments, but we moved all the sediments and the beer with the sediments through the machine, because that was the reason for centrifugation and this application. So what we found here, let's talk about myrcene. We found that at the beginning we had nearly 90% losses in myrcene, and later on it was less losses, and at the end, in the last liters, we have seen that the losses were only 55%. We were very surprised about this, and we found the same behavior for cariphyllene, for farnesene, for humulene, and also for limonene. All these mono and sesquiterpenes behaved the same. What does it mean? With regards to filtration process, where I was talking about, these compounds are only removable if they are bound to a solid particle. And that is the same for centrifugation, because centrifugation is working with the G-force of the machine. And only if a molecule like myrcene is bound to a solid compound, if it is a troop compound or if it is a yeast cell, then it's able to be removed out of the beer flow. And that is something I can, yes, I have to repeat again, that we think that these compounds, these mono and sesquiterpenes, tend to be bound to a solid particle, and then they're able to sediment, and then they're also able to remove. That is something it's not proven 100%. We will do it with more intensity in the future, but that is a trend that we have seen, and that is something that we have to know, and that's also something that we have to keep into consideration when we are producing beer and when we are looking for homogeneity. Okay, coming now to the beer on the shelf. Now the beer is already packaged, is sent to supermarkets or whatever, and the situation there on supermarkets on the shelf are very different. We have some good shops, they have refrigerators where the beer is on best practice, cold temperature, and otherwise we have supermarkets where the beer doesn't matter, it stays in very hot conditions there for weeks and months, and something will happen there, and that is what we want to show you now. So we made a storage tray with dry hop beers in bottles, and we had a sample in keg, and then we checked the beer after 3, 6, and 12 months, and the bottles were stored under warm and also under cold conditions. The keg was stored under cold conditions together with the bottles. Warm condition means ambient temperature in an office around 20 to 24 degrees centigrade. Talking about linalool first, we have seen with all the other examples from the other slides, from the earlier slides, that linalool is very straight going through the process. We don't have seen bigger losses. So it seems to be very stable from or we know that it's very stable from the brew house into the container, and that's also available for the bottle and also for the kegs. That is what we can see here on this slide. So we can draw a line here on these columns, and it's more or less the same values. We have no losses of this linalool that we once measured in the fresh beer. Now we go to the opposite side of this trial. We go to the myrcene. So let's have a look what happens with the myrcene. And again, we measured the value here at the beginning, at the fresh beer. It was the same beer, so the value was the same. And then after 3 months, especially under warm conditions, we see high losses coming up, and more losses after 6 months regarding the warm bottle. And after 12 months, we were not able to determine myrcene anymore in these warm stored bottles. So something is happening here that is very dominant, and it's also changing the hoppy character, the hop aroma character and hoppy note of the beer tremendously. Coming to the warm stored, to the cold stored bottle, we see here, okay, we have slightly losses, but it goes also down, especially here in between months 6 and 12. And for the draft, for the cold draft beer, we see losses until month 6. They are visible, but not that dominant compared to the bottled beer. But in practice, we know that normally draft beer has a shorter shelf life on the label than bottled beer, because the distribution of the brewery wants that the empty keg comes back, and so short shelf life helps to bring the empty keg back to the brewery. So 12 months are relatively unknown as far as I know. But we see something happens there as well with the beer in the keg. So coming to the second trial that we made with dry hop beers, it was only in bottles. We stored it 6 and 12 months on the cold and warm conditions. So let's start with the myrcene. So that seems to be very dominant involved in this, let me say, environment. And here's the value from the fresh one. It's absolutely over the threshold. Even if the threshold is 400 microgram per liter for this beer, we are over the threshold, and we have an impact of the a perceived impact of this myrcene. And then after 6 months, we see the differences between the cold stored and the warm stored beer, and especially after 12 months, we see that myrcene is going down wherever it goes through, but this value goes down, and there comes a moment when we are below the threshold of the myrcene, maybe, and then the complete characteristics, the complete aroma fingerprint of the beer is changing. So it's not the same anymore than when it was fresh. Now let's have a look on the other hop aroma compounds from this trial number 2, how they behaved. And here we see, excuse me, and here we can see that our levels or our values for linalool we measured were more or less constant over the 12 months, even for the warm stored beer. Then we come to the next sesquiterpene, that is humulene, and caryophyllene as well. They behave nearly the same and goes into the same direction what we have seen from the myrcene before. So we have losses, we have tremendously losses here for the humulene and for the beta caryophyllene as well. And that also has an impact on the flavor composition of the beer as well. And even after 6 months, the beer will not be the same than it was in the day it was filled up into the container, into the bottle. And then finally, let's have a look on the alpha terpineol. And here we see something that is very special. I come later to this phenomenon. We had a very low level of terpineol in the fresh beer, and then it was increasing steadily. And here at the end, after 12 months, especially under warm conditions, we have 6-7 times more or higher alpha terpineol concentration compared to the fresh beer. But all in all, the threshold of alpha terpineol will be around 300 to 330 microgram per liter, so we'll never reach this level here in this beer. But it shows that something is going on the shelf in our bottle, and we know that there are synergetic effects. So it could be that an increasing amount of alpha terpineol, even below the threshold of this compound, can have an impact together with other aroma compounds. So something is changing here and something is going on. And how can we describe this phenomenon that happens there with the alpha terpineol? Something that is also, or was presented by myself several times, that is the biotransformation of geraniol. And we have hop base geraniol as a free molecule and also bounded in a precursor form, let me say, for example, to a glycoside. And this goes into solution, not only by dry hopping, as well it goes into solution in the brew house in late hopping. And that forms, over different steps, beta citronellol and also alpha terpineol. Something like that was found out by a well-known scientist, Mr. Takoi from Japan, and it was released in the Brewing Science in 2016. And this shows the reaction from geraniol to beta citronellol, or it goes the way over linalool to alpha terpineol. So what's responsible for this? We have different hop varieties, and they all show different concentrations of geraniol and also of geraniol precursors. And that is something that can be described as a kind of fingerprint of the variety, especially Bravo and Sultana they have a very high potential of geranol and of geranol precursors. So there's a big potential to form these compounds by the biotransformation. So biotransformation is running by released enzymes, and these enzymes, mainly we can talk about beta glucosidase is coming from the yeast. It's not something coming from the further brewing or from other brewing processes. It's coming from the yeast cells, from microorganisms. They are able to release this class of enzymes where the enzyme can split the geranol molecule from the sugar molecule, and then we have free geranol, and then this biotransformation can start and can go on. It starts with the beginning of fermentation when yeast is able to form these enzymes, to bring these enzymes out of the yeast cell, and we know there's a coexistence from these compounds in this mechanism, and that leads also into synergetic effects I mentioned before. The citrus lime-like character of the terpene alcohols will be enforced by this biotransformation that is started or influenced by the enzymes from fermentation. So it's very important to know, and what we have seen before with the alpha terpenol can be linked directly to this happening if the enzymes are involved in this beer on the shelf, or is it happens because of the low pH of the beer. That is something that needs to be proven and comes up in the near future, but something is going on there. Now we go to the cans, because we think that beer cans are very important container, especially for dry hop beers. And if we have a look on the market, go to the United States of America or to other countries where craft beer is very dominant, you will see that there are more and more cans coming up, more and more beer on the shelf, dry hop beers filled up in cans, and the number of bottled beers will go down. And that has the reason in the can itself, because the can looks like that it's a very closed container, and the changes that we have seen regarding the beer glass bottle, they are not to find here in beers filled up in aluminum cans. Have a look here. That was a trial that we made with dry hop lager beer in can after 6 months under warm conditions. Remember what happened with the beer in the bottle after 6 months under warm conditions. We see slightly reduction of myrcene, but all the other compounds, they stay more or less very stable. We see a slightly increase of terpenol here as well, but let's have a look also on the analytical deviations. And so I would say nothing really big happens there in this trial. And another trial we made with canned beer for 30 months under dark conditions at 10 degrees centigrade. So it's a long test on the shelf. It's a little bit unusual because there will be nobody on the market who makes who prints 30 months of best before date on his dry hop beers, but something that shows us the behavior of the beer in the can. So that is the value of myrcene. Remember, we found losses of myrcene for the beer in the bottle that was going down this way, and here we see this one is more or less very stable. Linalool is also more or less very stable, slightly increase here after 30 months. And beta-carotene was on a low level and is still on a low level after 30 months. And for the alpha terpenol, we see a tendency that shows the same effect that I mentioned before. So to bring all the informations on a line, we can say that the best container from our side to bring especially dry hop beer on the market that is focused on hop aroma is the beer can. And also the question is, what is the problem with the glass bottle? So we had a deeper look into the crown cap, into the crown cork, especially regarding the seal, the cap seal. Inside, we took under our investigations and we made a beer. We had a fresh beer, and also a beer after 6 months under cold and warmer conditions. And then we started to peel off the sealing material from the crown cork. That's around 0.2 gram in total. And then we found a way to analyze hop aroma compounds out of this. But at least it was the idea to find something. So the determination values are not that that important, but it was our interest to find hop aroma compounds in this material. So these are the results. We see the linalool shows as well a very stable behavior over the shelf life under cold and also under warm conditions. The value of linalool in the seal was be able to determine, but on a very, very low level. So something of linalool was also to be found in the compound of the seal. Have a look on the myrcene, that behaves completely different. We see as well the losses in myrcene here in the beer over the 6 months, especially here for the warmer one. And we also found, let me say not dominant, but we found a very high concentration of this myrcene here in the seal material of the crown cork. And we say, okay, if we can find it in the plastic, in the seal material of the crown cork, it's also possible that the myrcene is leaving the seal material and goes into the atmosphere, and this can maybe describe the losses that we have of certain aroma compounds, especially the mono and sesquiterpenes in beer over the shelf life. And I think that is the reason why we have this very dominant differences in between bottled beer and the beers in can. Now let's have a look on the beer turbidity. So what happens with the beer that comes in the container in a cloudy form? There's haze inside, and then after a while the haze begins to settle down. That is something to describe as a physical effect, and you cannot stop it. That is also something you find with Bavarian style wheat beer, that after a while the turbidity sinks down to the bottom of the bottle. My colleague Dr. John Paul May in the US, he made the New England IPA investigations 2 years ago, and he had 12 different commercial New England IPAs from the shelf, from different suppliers, stored them at 3 degrees, and then over 5 months he measured the turbidity of these beers, and without any homogenization before measuring. He put the beer out of the bottle, and the sediments were still remaining on the ground of the glass. What we can see here is very dominant losses, especially in the first month, that the hazy material begins to settle down to the bottom of the glass bottle. And that is the effect you cannot stop normally. And to be honest, to really stabilize this high value of turbidity, let's talk about 100 to 160 EBC, it's without any chemicals or technical things, it's impossible. The material will go down, will sink down, and then below 50 EBC, it's also visible that the turbidity of the beer is will be removed. Then he tried to go deeper into his investigations, and he had a look on the hop-derived compounds in these beers. So he decided to take 2 beers, beer number 1 and beer number 2, and these beers were centrifuged, and we see that the turbidity before and after centrifugation was different. So there was a centrifugation effect, that hazy material was removed from the beer phase. Then he had a look on the humulinones and the isoalpha acids. These bitter compounds, they nearly behave without any changes. So they are very good soluble, and they stay in the solution in the liquid phase of the beer. On the other hand, we have these non-polar hop compounds, which tend to, let me say, try to leave the liquid in any way. And he found out that these compounds were more linked to solid particles and removable by the centrifugation of the solid particles. And especially here for the beta acids, very dominant. It's normally a compound you do not find in a regular beer, but because of the high hop load for the New England IPAs, the level was also very high, but a lot of removal here by centrifugation. And that was the same for the aroma compound myrcene as well. So myrcene was then only half after centrifugation regarding beer number 1. And so that means that the other myrcene compounds or myrcene molecules must be removed together with the haze. Then my colleague, he freeze-dried and then he analyzed the haze, the precipitated material, and it's not that surprising that he found a lot of proteins, he found a lot of starch, and he found polyphenols, because that's something that's very common. What we know that haze-forming compounds are from this side. And he also found nearly 1% of fatty acids, C18 molecules from linoleic, and from oleic acid. And that's something that we were surprised about, and it's not really clear where these fatty acids come from. Is it or are these fatty acids from the hops, or does it come from yeast cells? That is what we have to find out in the future. But with a look on the really hop-derived compounds, we can see that in this hazy material, there's a lot of myrcene. It looks like that is not very much, with 0.1 milliliter per 100 gram. But if you calculate this to a gram of hazy material that is sitting there on the bottom of your bottle, then it's relevant, and it's equivalent to 8,000 microgram myrcene per gram of this material. So if this myrcene is bound to hazy compounds, it's settled down to the bottom of the glass of the bottle or in any other container. It's the same in the keg and in the can as well. Then it's out of the beer. So if you pour the beer into a glass, or if you drink from the container without homogenization, you will have a different taste sensation than with a fresh beer. That is a big difference here by just sedimentation. So coming to the next one, that is a light impact that is here on hop bitter substances, and is also changing the flavor of a beer on the shelf when daylight is coming to the product. And this 3-methyl-2-butene-1-thiol, 3-MBT, is very common. That is the light struck aging compound that we all know, that we hear about. And this the formation can only start at UV light wavelengths around 350 to 500 nanometers. And we need iso-alpha acids as a starting material. We need the riboflavin, vitamin B2 as a, let me say, kind of catalyst. And we need a sulfur source that comes normally from proteins, where the SH group here comes from in the 3-MBT molecule. Problem is that the threshold of this molecule is very low. Have a look on water. That is from literature, people say it between 0.2 and 0.3 part per trillion. That is nanogram per liter, 0.2 nanogram per liter. And regarding beer, the matrix is a little bit different, and beer is able to handle a little bit more concentration, higher concentrations. So it's in between 4.0 and 35 part per trillion, 4 to 35 nanogram per liter. So very low threshold. And so to avoid the formation of 3-MBT out of iso-alpha acids, needs to eliminate or to avoid any impact from iso-alpha acids on the whole process of your beer production. So what can help to stop or to eliminate the formation of 3-MBT? Regarding packaging, we know if we use darker glasses, the wavelength is cut off below 500 nanometers, so the effect is not there. On the other hand, if you have white glass or green glass, the effect happens very well. Then some producers started with protection layers on glass bottles, and also with some optical filters, here especially on refrigerators where you have a constant illumination, and also for packaging material. And you can also remove the formation or eliminate the formation when you put the bottles directly after filling into cartons, or at least in a closed six-pack. That also helps a little bit. And you will not find this phenomenon in beer that is filled up in cans or in kegs. That's logical because there's no impact from daylight. It's also possible to talk about a masking effect against 3-MBT, especially when you are able to use hop oils. These products are 100% light stable into your beer production to eliminate formation of 3-MBT. And maybe there are other additives or other aroma compounds, aroma groups who helps to mask this off flavor, but I think more or less you want to avoid it, that it occurs. From our side, from the hop side, we know that the reduced pre-isomerized hop products like light stable kettle extract or raw iso extract, tetra or hexa, these modified hop iso alpha acids have no tendency to form 3-MBT. So if you want to make a beer without formation of 3-MBT from hop bitter compounds, it's recommended to use these guys, but something have to be also considered regarding this formation of sulfuric compounds with a very low threshold. It's not coming, or not all is coming from the hop side. We made a project in 2012. It's a university in Munich, Weihenstephan, and by bringing beer or setting beer to sunlight, we found that the MBT was produced out of iso alpha acids over the threshold. So it was an impact from the MBT on the sensory impression. But we also found other compounds like 3-methyl thiopropanol and dimethyl disulfide on a higher concentration than the threshold. And these compounds, they are not hop derived. They are, I think that they are B malt based. And so it's not all coming from the hops. Also, something might come from the other raw material side, from the grains. So if you want to avoid formation of this light struck character, then you have to avoid the sunlight coming to your product. And now finally, last point for today, that is the mystery of linalool. And we all know that linalool is let me say, a key indicator for hop aroma intensity, especially regarding late hop beers, hopped in the kettle or hopped in the whirlpool. And it's not only linalool, but linalool is just a key indicator. There are other compounds as well involved, like geraniol, for example, but it's easy to detect linalool. And what we found in the past is when we do our recommendation regarding late hopping, we calculate always the dosage, the hop dosage to linalool, and that happens and works very well. So linalool is very important for the hop aroma in beer, but there's something behind linalool that we should have known, because it has a chiral center in the molecule, and by the chiral center, it's possible to find two enantiomers of linalool, that is R- and S+ linalool in the world. And the difference is the threshold. For the R linalool, threshold is very low. In beer, it's between 5 and 10 microgram per liter. But for S linalool, it's much higher. It's around 400. And that is a big difference. Even the molecule looks the same. The aroma impression is a gap in between the aroma impressions of these enantiomers of linalool. And it's given by nature. You have a certain ratio of linalool in all hop varieties. The total linalool concentration depends on the variety. That's also part of the fingerprint of the variety. But we see that the ratio of R of the high high aroma profile linalool is between 92 and 94 to 8 to 6% of the S of the low intensive form of linalool. So there's a big difference, but everything in the fresh hops looks like it's on the side of the relevant of the R linalool. Then we measured linalool R and S enantiomers in raw hops. That was the result. Also in hop oils from these raw hops, we got the same result. So there was no impact by the hop oil processing. And that is a very new information that came up last week. After 24 months of one of our hop oil products that has a shelf life of 24 months, we saw the same concentration of the R and of the S linalool in the final product. So nothing changed, and there was no aging, let me say, aging inflicted here in the formation of more S linalool and a lower concentration of R linalool. The values here in beer that we found, that was work from my colleagues in the past. So yes, it depends on the beer style, it depends on how it was produced, it depends on the age, on the situation on the shelf, that the R linalool values can differ in between 52 and 94%, and also when the R goes down, the S linalool concentration goes up. But if this is a fact, we have the sensory effect that the impression from linalool goes down dramatically when we have losses in R linalool and increasing values of S linalool in the beer. And one thing that we also can, or was proven in our house by my colleagues, Mr. Mitter, Dr. Bean, and Dr. Kaltner in the past, the impact or the influence coming from the pH regarding the two enantiomers. The lower the pH is, the more of the S linalool is formed, and then the ratio of R to S linalool is changing in direction to the S linalool. So the intensity, the aroma intensity goes down regarding linalool. Okay, coming now to the end, it's time to stop. With a short summary, we have seen that we have to have an eye on the changes at the end of our production before we start filling the beer in any kind of containers. We need a homogenization that's very important, especially for dry hop beers. We also have seen that there are a lot of losses of non-polar aroma compounds, especially in bottled beer, and that the can is, for me, the right container for this group of products, namely the dry hop beers. And we have seen that haze can also accumulate non-polar hop compounds, and in the sediments we found a lot of them, and in the beer phase we get rid of them over the storage time. We have seen that the daylight has an impact on the formation of light-struck flavor and compounds, but it's not only the alpha acids from the hops that are involved, the iso-alpha acids that are involved is also the malt that gives some compounds with tends to form light-struck flavor of flavor in the beer over the time. We have seen the chiral character of linalool and the differences between the R and the S linalool, and that we have to keep in the consideration. If we measure total linalool in the beer and the value is always the same over the shelf time, then it does not mean in the same way that the ratio of R to S linalool is unchanged, and that has an impact on the aroma impact coming from this aroma compound. And we also have to know that we have a lot of synergetic effects in between certain aroma compounds and groups, and this presentation was completely related to analytical results, and is also very important to have an eye on the on the sensory element and on the sensory results regarding these effects that I demonstrated. Now I thank you very much, and I give the word back to my colleague Sandro.
Yes, hello Frank, thank you very much. very complex topic. You have mentioned it from many different point of views, from the light stability to the dry hop beers and how they behave in the different packaging sizes. So I can imagine you can talk even 2 hours longer about this topic, but I guess you gave a very nice overview about a couple of things to be considered when talking about hop aroma and the aging of the beer. And thinking about a suitable best before date. Yeah. Okay. Well, I'd like to pick up a couple of questions. So far, the questions that we have are all related or mostly related to the dry hop beers, as far as I understand them. So let's start with the first one. On this page 10, you already showed a nice summary about the various flavor components and how they behave during filtration with diatomaceous earth. Do you have more information how they behave if when on the effect of on PVPP? Is there an effect of the quantity and so on? Do you know more info about that?
We have no special information regarding PVPP or Kieselgels because that was not a part of our trials that we made. We were looking to do this as well, but it's also hard to find a partner who is filtering dry hop beers because it's a little bit unusual. But we see that more guys are doing this to make a more constant quality of the beer by the effect of filtration of dry hop beers. But it's something for the future. You're right.
Yeah. So, but if somebody is listening right now who's using both to filtrate the dry hop beers, it might be a good setup to have a closer look on this. So, in this case,
Yes,
just contact us.
he needs a closer look on this, and also he needs a closer look on what happens in the next step of filtration. If there is a sheet filter involved or any kind of cellulose, because that also has an impact. And my recommendation is if there are more questions about this, please have a look into the paper that we released in the brow industry.
Yeah, good point. Yes, it is also on our website. Yeah. Otherwise, drop us an email. Another question that came up is about yeah, the packaging. So if let's say let's have a maybe you'd like to summarize again the differences for a late hop beer depending on the package and the differences of the dry hop beer. For example, the question came up especially for the dry hop beers, what is the most suitable package? And you have shown that the bottle and cans and kegs behave different. So maybe you just like to give a very short summary about that again.
Yes, let me say we have two kind of beers. One is with a late hopping character, and one is with a dry hopping character. So regarding the late hopping character, everything is more focused on these terpene alcohols and on some esters. And these compounds, they stay very stable along the whole process, and they also stay very stable even if they are in a bottle or in a can. And on the other hand, we have the dry hop beers where we have the volatile compounds like the mono and sesquiterpenes and ketones and other guys. And these compounds are non-polar and they tend to leave the bottle. So for these dry hop beers, the can is the best solution.
I remember a trial where we also focused besides the analytical values on the sensory, and where we compared a beer that was bottled and we kept it in the keg as well. And after 9 months, I would say both beers were not the same in the beginning. If I wouldn't have known it, so I can imagine that they both beers go a very different way sensory wise, but also as you have shown today with the analytical data.
Absolutely, Sandro. And you have to have an eye on the differences between a beer in a keg and the beer in bottles or cans, because the sedimentation in a keg has much higher impact than in a smaller container. Because if you move a smaller container, you bring easily the sediments back into solution. And when you have a big keg with 30 or 50 liters, and it stays for a while in a cold warehouse, and then it settles down completely, and then you start with a very cloudy one at the beginning, and the last beer that comes out looks like filtered. So they have different qualities in different layers in a keg. That's something that people have to know, especially when it's unfiltered or when it's dry hop beers.
And considering also the data that you have shown from our colleague John Paul May about the NIPAs, especially the aroma also sticks on certain haze particles, which is also a question that came up. So, for example, especially for the fatty acid components that you have shown, do you think that other raw materials like oats and so on could contribute a lot to the fatty acid concentration in those beers?
They maybe do, but we also produce 2 New England IPAs here in our brewery. Without oats, we only used barley and wheat malt, high dosage of wheat malt on this, and we found very big differences regarding the foam stability. Compared to the base beer from the same brew, we had very high loads of dry hopping, more than 3 kilograms, and these beers show very bad foam stability. And maybe we can link the bad foam stability to the fatty acids, but that's something that is for the future. That's work for the future for us. But maybe the fatty acids can have an impact on foam stability. Yeah.
Okay. Well, then we have already a topic for next year. So hops and the contribution on foam, and with a special view on beers that are also produced with other raw materials like with the oats and so on. Okay. Well, we are exactly on time. I would say it's time to close the session. We have answered all questions that came in. And thank you again, Frank, for the very interesting presentation. And I would like to give a note again on the many related papers about today's topic that can be found on our website, www.hopsteiner.com. There you find the section technical publications where more information is given. After closing the webinar now, you have the chance to give us a very short feedback if you answer 2 questions, if you like to do so. And you will also receive an email to rewatch the recording of today's session. Finally, I'd like to say that we have the next webinar on the 5th of November. Our managing director, Joachim Gede, will present the annual guidelines for hop buying. Topics like changes in the hop market and an overview on the crop 2020 will be discussed, especially with a view also on the impact of the COVID-19 situation. Okay, Frank, this is your last chance to say goodbye. Otherwise, I close the session.
I want to say goodbye to everybody and stay healthy. And let's go through this disease, and then we will see us again live.
Perfect. That's a good point. Good. I close the session now and thank everybody for joining us, and we stay in touch. Bye-bye.